A deployed model is not finished. It enters a maintenance loop. CCD helps ship changes safely. Monitoring shows how the system behaves in the real world, and retraining responds when data or performance shifts. Together, these practices keep machine learning systems dependable over time. You've already covered the core MLOps mindset, the lifecycle, tools, patterns, and why DevOps skills matter. You also built, tracked, packaged, and deployed a simple model as an API. Now the focus shifts to production operations, automating deployments, monitoring behavior, and retraining when real-world conditions change. Deployment is only a checkpoint, not the finish line. After release, a model still depends on the data it sees. If customer behavior changes, markets move, or input patterns drift, accuracy can drop even when the application code remains stable. That is why monitoring is a core MLOps practice. Teams watch for signs of degradation, then retrain with newer or better data so the system stays aligned with reality. An MLOps CI/CD pipeline begins when a change is committed. From there, automation takes over. Standard tests catch code, API, and workflow issues. Model validation checks whether the candidate still meets required metrics, such as accuracy or latency. If it passes, the system builds a deployable package, pushes it to a registry, and deploys it to Kubernetes. The result is a repeatable path from experiment to production release. Most automated delivery starts with a Git event. A developer or data scientist commits code, opens a pull request, creates a tag, or relies on a schedule. That event triggers checks before anything reaches production. Branches keep experiments isolated, while pull requests add peer review and automated testing. When checks pass, changes can merge into main, and the deployment pipeline can build, test, approve, and release, with traceability back to source control. Testing is the safety net for every model change. Unit tests protect pre-processing and helper functions. API tests confirm that prediction endpoints return the right status codes, formats, and errors. Data tests check schemas, missing values, ranges, and feature expectations. Pipeline tests make sure training, packaging, and deployment still work together before anything reaches production. Before deployment, a candidate model has to prove it is better, or at least safer, than the current baseline. Validation compares metrics such as accuracy, precision, recall, RMSE, latency, and business KPIs. It also checks for bias, data leakage, and sudden performance drops. If thresholds are missed, the gate rejects the model. If results are strong and critical use cases are approved, the model can move forward. Once validation is complete, the service is packaged as a Docker image. That image includes the model, API code, dependencies, and runtime. It is tagged so each build can be traced by release, model version, or commit SHA. Before use, the image is scanned for known vulnerabilities. Then it is pushed to a container registry, which becomes the source for deployments into development, staging, and production. With the image in the registry, the pipeline asks Kubernetes to run it as model API pods. Those pods are exposed through a service or ingress, giving users a stable endpoint while Kubernetes handles scaling and replacement. Promotion usually moves from development to staging, then production. To reduce risk, teams use rolling updates, blue-green swaps, or canary releases. Before production, an approval gate, manual or automated, checks quality signals and prevents unsafe releases. Think of GitHub Actions or Jenkins as the runner for your CI/CD recipe. A push to the repository triggers the workflow. Then commands install packages, run PyTest, build a Docker image, and push it to a registry or deploy it. GitHub Actions keeps this in YAML beside your code, while Jenkins uses pipeline scripts and agents. Secrets handle credentials safely. Monitoring is the feedback loop after deployment. First, we check whether the service is alive. Uptime, status codes, error rates, and latency. Next, we watch the inputs and usage, prediction volume, missing values, unusual distributions, or drift. When labels or outcomes arrive, we compare predictions to reality and track model quality. The key idea is simple. A model can fail as software, as infrastructure, as data changes, or as a decision system. Production monitoring starts with the basics. Is the API up, fast, and stable. Track uptime, request volume, status codes, and error rates to spot service failures quickly. Measure latency with percentiles, especially P50, P95, and P99, because averages can hide slow user experiences. Infrastructure signals matter too: CPU, memory, pod health, and container restarts. When thresholds are crossed, alerts turn measurements into action before users are seriously affected. Models are trained on a snapshot of reality, but production reality keeps moving. Data drift means the inputs change. Ranges shift, categories appear, missing values increase, or outliers become common. Prediction drift means the model's outputs start changing in unusual ways. Neither one automatically proves the model is wrong. They are early warnings. By comparing live feature statistics and prediction patterns against training baselines, teams know when to investigate, retrain, or adjust the system. Retraining should not be a panic button. It is a managed loop. Monitoring signals, scheduled refreshes, new labels, drift alerts, or performance drops can trigger training for a candidate model. But that candidate does not replace production automatically. It must pass validation and testing, then be registered with version history and metadata. Only approved models are redeployed. After release, monitoring continues, so each production cycle creates evidence for the next improvement. You've now completed the production loop of MLOps. CI/CD makes releases repeatable and controlled. Monitoring shows whether the service, data, and model are still healthy. Retraining closes the loop when patterns change. Your next step is practice. Apply the full lifecycle in a hands-on project or team workflow.